Hi all, in this class we are going to see what is channel coding theorem. So this is Shannon's second theorem and we already studied Shannon's first theorem, that is for source coding, and this Shannon's second theorem is for channel coding. So mainly it consists of two parts. For to define this, first we are taking a discrete memoryless source has the source alphabet S and entropy H of S bits per source symbol. Then we assume that the source emits symbols once every TS second. So the source emits symbols once in every TS second. So we can say that the average information rate of the source is nothing but entropy into the symbols rate. So we can say that it is H of S by TS bits per second. Then we are taking the discrete memoryless channel has a channel capacity equal to capital C bits per use of the channel. Then we assume that the channel is ready to use once every TC seconds. So the channel is channel we are using once in every TC seconds. So our assumption that our symbols entropy H of S is the symbols emit once in every TS symbols will emit once in every TS second. Similarly, we are taking the capacity of channel is equal to C and we are using this channel once in every TC second. So we can say that the channel capacity per unit time is nothing but C by TC bits per second. So that represents the maximum rate of information transfer over the channel. So we already defined that the capacity is defined as the maximum rate of information transfer over the channel itself. So using this background, we are going to define the Shannon's second theorem, that is the channel coding theorem. So it consists of two parts, and first one, let a discrete memoryless source with an alphabet S have entropy H of S for random variable S and produce symbols once every TS second, and let a discrete memoryless channel have capacity C and be used once every TC second. Then if H of S by TS less than or equal to C by TC, what will happen? So that means there exists a coding scheme for which the source output can be transmitted over the channel and be reconstructed with an arbitrarily small probability of error, and that is called channel coding theorem. That means the entropy of source H of S emits symbols once at every TS second, then the condition is H of S by TS is less than or equal to C by TC. Then that means the average rate of information of the source should be less than or equal to channel capacity per unit time. Then we can say that then only there exists a coding scheme that for which the source output can be transmitted over the channel and we can reconstruct the same with very low probability of error. So if H of S by TS should be less than or equal to C by TC, then only we can use a source coding scheme, or we can use a coding scheme to obtain a small probability of error. And the parameter C by TC is called the critical rate. And when these are equal, then the system is said to be signaling at the critical rate. That means if H of S by TS is equal to C by TC, then we can say that the system is said to be signaling at the critical rate. That means the system is operating at the critical rate. So the Shannon coding theorem says that if H of S by TS less than or equal to C by TC, then only there exists a coding scheme that will produce a low probability of error, and we can easily reconstruct our symbols at the receiver side. And the second part, we can see that this H of S by TS is greater than C by TC. What will happen? it is not possible to transmit information over the channel and reconstruct it with an arbitrarily small probability of error. So, if this h of y, average rate of information, is greater than the channel capacity, we can't possible to transmit our information over that channel, and it can't be possible to reconstruct the channel with low probability of error. So, this theorem states that the channel coding theorem. So, the theorem specifies the channel capacity C as a fundamental limit on the rate at which the transmission of reliable error-free messages can take place over a discrete memoryless channel. So, how we can transmit information through a channel with low error probability? That is, the question is the fundamental limit for that is the channel capacity itself. So, the disadvantage of this theorem is that the channel coding theorem doesn't show us how to construct a good code. So, that is the main disadvantage of this theorem. This theorem specifying that if we are using h of s by ts is greater than c by tc, we can't possible to transmit the information over the channel. But it doesn't show that what is the code we can use for construct a code for low error probability. It doesn't give a technique to produce a good code. So, then next is the theorem doesn't have a precise result for the probability of simple error after decoding the channel output. So, these are the main disadvantage of this theorem. That means the theorem doesn't show us how to construct a good code, as well as the theorem doesn't have precise result for the probability of simple error after decoding the channel output. So, that's the channel coding theorem. So, we can also define this Shannon's theorem on channel capacity, or Shannon's second theorem, or Shannon's theorem on channel coding using the rate of information of transmission also. We already said that h of s by ts represent the average rate of information. So, when the rate of information transmission rt is less than or equal to c, then there exists a coding technique which enables transmission over a channel with a small probability of error as possible, even in the presence of noise in the channel. So, this theorem states that if our average rate of information, is RT less than or equal to the channel capacity, then we can transmit our information through a noisy channel with low error probability. To transmit that, there exists a coding scheme. So, we can use if the condition is RT is less than or equal to C, then we can say that there exists a good coding technique to transmit our information through this noisy channel with low probability of error. So, we said that for RT less than or equal to C, transmission without error, even in the presence of noise, we can possible. What will happen if RT is greater than C? Then we can say that the reliable transmission of information is not possible without errors. So, it says that if RT is greater than C, the reliable transmission is not possible. Then when RT is greater than C, then the errors cannot be controlled by any coding technique, and probability of error of receiving the correct message become close to unity. That means it is not possible to transmit our information when RT is greater than C. So, because the errors cannot be controlled in such cases when RT is greater than C. So, this is called channel coding theorem. So, basically this channel coding theorem specifies that how we can transmit, what is the fundamental limit for transmission over the channel. So, that result is the channel capacity itself.